Hey, welcome back to trigonometry. We are still looking at our test prep. This is number 13b, and we have to graph y equals, negative 4 cosine 2x plus pi over 3 plus 2. It says to graph at least 5 points, so that's what we're going to show you how to do. All right, so a couple of things that I have to remember is that we have an offset. We have a vertical offset of positive 2. We have a reflection of this negative sign out in front, and we have a amplitude of 4 here. All right, so first thing I'm going to do is I'm going to go ahead and think about, what's going on with this? Um, okay, there we go. It's like I'm not drawing where I think I'm drawing here. Okay, so we have that. It's weird to see it on your page and not know exactly where you are. So that's my x equals 0. This is my y equals 0 line. Okay, x, and then we have our y. All right, and then the first thing I'm going to do is here's my y equals 2, right? Because there's a vertical shift of 2. All right. Now, I've got a couple of points that I really want to graph. I want to graph my maximums and my minimums, or the beginning and the ending of everything. We'll go ahead and figure that out. The way that I like to do this is with the anchor points method. Like I come up with the points that I need, and then I hang the graph off of the points that I have plotted. And for just a parent function cosine, the numbers that I know I really need are going to be 0, pi over 2. Okay, pi, 3 pi over 2, and 2 pi. So what I'm trying to do is I want the argument. I want to figure out what x has to be so that 2x plus pi over 3 is equal to 0. Well, there's a way to do that. We're going to say 2x plus pi over 3 equals 0, and we're going to solve for x. So that's 2x is equal to negative pi over 3, right? Well, subtracting pi over 3 from both sides, and then divided by 2, and we'll say that x equals negative pi over 6, right? That's going to be my phase shift, by the way, is a pi over 6 to the right. Okay. The next thing we're going to do is we're going to say, okay, and you don't have to do these in order. We could say this is 2x plus pi over 3 equals pi. I skipped the pi over 2 for a moment. We're still working through this. So we're going to say this is 2x is equal to pi minus pi over 3. Now, I can't say pi minus pi over 3. There's fractions involved here. We've got to get common denominators and figure it out that way. So instead of pi, I'm going to say pi is actually 3 pi over 3. All right. Now, 3 pi over 3 minus 1 pi over 3 is going to give me 2 pi over 3. So I've got 2x equals 2 pi over 3. The last thing I'm going to do is I'm going to divide by 2 and say, okay, this is going to be 2 pi over 6. And you're like, but you can reduce. Like, yes, you can. Give me a moment to decide if I want to reduce or not. Okay, because now I'm going to do 2x rather, plus pi over 3 is equal to pi over 2. And we're going to do the same thing. So we're going to subtract pi over 3 from both sides. So we have 2x is equal to pi over 3. I'm sorry, is equal to pi over 2. That's what I wanted to say, because we set this thing equal to the pi over 2. That was my next anchor point that I've got. Pi over 2 minus pi over 3. Now, here I've got a pi over 2 minus a pi over 3. I'm going to have to figure out how to get these guys together because we want a common denominator. So I'm going to multiply the first one by 3 over 3 and the other one by 2 over 2, and that will give me 3 pi over 6 minus 2 pi over 6. Well, 3 pi over 6 minus 2 pi over 6 will give me 1 pi over 6. So I've got 2x equals pi over 6. And the last thing I'm going to do is say, well, let's go ahead and go ahead and divide by 2. So I have x is equal to pi over 12, dividing both sides by 2 here. All right. Here's a little trick that we're going to deal with this because it looks like everybody's going to be in terms of twelfths. So there's always going to be a pattern that you can exploit here. So let me go ahead. I'm going to multiply this piece by 2 over 2. So that's going to be negative 2 pi over 12. We've got 1 pi over 12. I'm going to multiply this by 2 pi over 2, or 2 over 2, and we end up with 4 pi over 12. Now, I'm going to say, okay, we have negative 2 pi over 12, 1 pi over 12, 4 pi over 12. I'm going to act like Dora the Explorer here and say, do you see a pattern yet? Like, well, maybe, right? I think if I add 3 pi to everybody, 3 pi over 12 to everybody, we'll just keep getting the next thing here. So I'm going to say, I'll bet my next problem, my next value is going to be 7 pi over 12. Let's see if that's true. So we went 2x plus pi over 3 equals 3 pi over 2. We'll go ahead and do the same operations. We have 2x equals 3 pi over 2, okay, minus pi over 3. And we have the same issue we had before. We have to go ahead and get common denominators. We have 3 over 3 and 2 over 2. So here we have 9 pi over 6 minus 2 pi over 6. Right? I'm just going through and multiplying this out. So we have 3 times 3 is 9 minus 2, and we end up with this is 2x equals 7 pi over 6. Now what I'm going to do is divide both sides by 2, and we have x is equal to 7 pi over 12. Hey, they match. Go figure. Okay, that's pretty good. So we can solve the last one, and that's what we're going to do. But on your exam, on your problem, if you said, hey, I'm pretty confident this is a plus 3 pi over 12 every time, right? We could probably look at this and say this is 10 pi over 12. And that's why I didn't reduce, it's because I knew I was going to be looking for a pattern, and reducing will obscure that pattern, so it makes it harder for me to see. I don't want to do that. So I'm going to make my guess and say this is 10 pi over 12. Let's go ahead and do that. So we've got 2x plus pi over 3 is equal to 2 pi. We'll go ahead and subtract. So we have 2x equals 2 pi minus pi over 3. And again, we got to figure out like thirds here, right? Because we just can't do this. So we're going to say 3 over 3 here, and now do all the problems that we need to deal with here. So that's going to be 6 pi over 3 minus 1 pi over 3. So 6 minus 1 is going to give me 5 pi over 3. So let's go ahead and not get ahead of ourselves. All right, so we went through and did that. So we have this as 2x equals, okay, 2x equals, and this was 6 minus 1. This is 5 pi over 3. Okay, we're going to divide both sides by 2. So we have x is equal to 5 pi over 6. And then finally, since everything else is in 12ths, let's go ahead and make this one in 12ths. We'll go ahead and multiply by 2 over 2 and then say, oh, look at that. It's 10 pi over 12. Of course it was. Okay, and again, hey, they match. That was my correct prediction. Those are my anchor points. So I'm going to go back up here and I'm going to say, well, my first point that I actually care about is going to be negative. I mean, it should be on the other side of the axis clearly, but you can draw it kind of where you need to draw it. Like that's one of the complaints I always get in my evaluations. I do read them. Um, that all your graphs always look the same. I'm like, I know. Okay, I know. But the thing is, I'm looking for these points down here to kind of scale my graph correctly. And we're looking for 10 pi over 12. Now, if I want to be really good about it, and I think I do want to be better about this today, we'll go ahead and we'll change my graph a little bit. So I have my axes sitting right here. We're going to go here. We're going to say this is negative 2 pi over 12. This is my positive 10 pi over 12. That was my last number. What was the one in the middle? It's 4 pi over 12. So I'm going to look and see, like, can I guess the middle of what's going on here? Like, kind of. Humans are pretty good at guessing middles. Okay, and that was going to be 4 pi over 12. And then we need half of that, which is going to be pi over 12, right? And then we need half of this, which was going to be 7 pi over 12, all right? And those are the first 2 points that I actually want to go deal with. Now, in a parent function cosine, okay, when I ask, like, what is the cosine of 0? I'm going to get the answer of 1. But we're going to take negative 4 times 1, negative 4. We're going to add 2 to that. So we actually need to be down here at negative 2. Okay, so I went here. This was 2. Let's try to see if we can't, again, get a consistent scaling. Okay, you don't have to get that much of a consistent scaling, but my statistics class will frequently not do a consistent scaling, and it kind of drives me nuts. So I'm trying to be good about getting a consistent scaling. But that's going to be negative 2. When I get to pi, right, I'm just trying to scale my graph here and figure out like how big and how tall do I have to make this thing. I know that the bottom of cosine is when x equals pi. Okay, when theta equals pi. So the cosine of pi is -1. When I multiply this -1 by the -4, get +4. We're going to add 2 to it. We're going to have 5, 6. So we have 2, 3, 4, 5, 6. So we're all the way up here at y equals 6. Okay, so we go to -2 down here. Okay, so actually I'm going to be, my first point right here is -2. When x is pi over 12, what were we supposed to get? If I plug pi over 12 back into this whole thing, let's go back over, down over here. I plug in my pi over 12. I can plug it all the way back in. I'm going to get pi over 2, right? If I plug in x equals pi over 12, we end up with pi over 2 for all this. But what's the cosine of pi over 2? It's 0. And 0 times -4 is still 0. And we add 2 to it. So we're going to be at our baseline. And we set this thing up right here. Okay, my pi over 12, that was the middle line. That was my, let's get up, it's pi over, that was pi over 12. 4 pi over 12, that was my, if I plug in 4 pi over 12, we end up with a theta of pi, and that's why I went through and did this one. Okay, and then we can go back and say, okay, we plug in x equals 4 pi over 12. If I plug in 4 pi over 12 here, we're going to go back to cosine of 3 pi over 2. That's back to 0. It's going to be on the baseline because we're going to go ahead and do all that arithmetic and get that. And then finally, I've got my last problem. Okay, that was 7 pi. And we're going to be back at 10 pi over 12. We're going to be back down here at -2. So this is going to be kind of a crummy graph because I didn't really scale it really well. But I know that my cosine, instead of looking like this, it's going to be upside down. So I want something like that. So what I'm doing to do here is we're going to see if I can't carefully kind of figure out what's going on here. It's going to come up here, pretend that actually connects the dots. Okay, and that's going to be one cycle of cosine with, I've got 1, 2, 3, 4, 5 points labeled, okay, and know where they are. I've got a minimum, I've got a maximum, I won't call them intercepts because we're not ready to get that point yet, but we'll call it adjusted intercept. Okay, where it crosses the midline. Okay, and those are the points that I have to graph for my cosine. Okay, I hope that was helpful. When I go to grade you, what I'm looking for is, did you get the correct amplitude? Did you get the reflection? The important thing is, did you get these points? Okay, that's what I'm really grading. Is like those are your points right there. Okay, both as points for graphing and points for your exam, points for your score. So that's what I'm really looking for is what's going on here. Okay, and did we get the midline? But these guys right here are the ones that I'm really concerned about. Okay, so that's how you go ahead and do a problem like this. That's how I like to do it. There are other ways to go about doing it. The book does a slightly different, has a different way of going about this than I do. I came up with doing this because if there was other questions that I had, because what if I want another period. I want one wavelength. Okay, normally you have to remember 2 pi over b. I did not remember this formula until I teach this class. Okay. When I took trigonometry, I did not remember this formula at all. I was like, I'm not remembering another formula. You got to be crazy. But I could figure out what the wavelength is because where is my endpoint? Well, my endpoint is 10 pi over 12. So 10 pi over 12 minus what was my beginning point? My beginning point is -2 pi over 12. Okay, so we could say 10 pi minus a -2 pi. That's going to be 12 pi over 12. My period is pi units long. What is my period? If I use this 2 pi over b, I've got 2 pi over b, which is 2. Oh, look at that. Our period is pi. They match. They're the same thing. So I developed this because I wasn't going to remember that. And then if you want to get the phase shift, what you have to do is you have to rewrite this a little bit, right? We have those graph adjustments, the graph transformations. You can do it. Like we have -2 cosine of 2x. What was minus? What was it minus? It was minus pi over 3. Okay. pi over 3 plus, so it was a plus or minus? It was plus pi over 3, of course it was. Okay. My arrangement here was, this is a 4 here. 4 plus 2. Okay. When you want to do your horizontal shift, you have to adjust for the fact that you've got a horizontal squish or stretch here, which means you have to actually factor that out. So the way you have to write this is 4 cosine 2, and then we're going to say x plus, I'm factoring out a 2, so that's going to be plus a pi over 6. Okay, so it's a pi over 6 to the left. Okay, where should I have started? I should have started at 0. Where did I start? I ended up at pi over, because now I'll reduce, right? This is negative 2 over 12. So this is actually negative pi over 6. I should have ended up with a shift of pi over 6 to the left. Oh, what do you know? They match about what we're doing here. Okay. So the reason why I do it this way was for me being extraordinarily lazy and saying, I don't want to memorize an extra formula and I don't want to have to remember how to do this factoring and figure, because I didn't know how to do this when I took trig. It was this was hard, and it still is. I get it. Like for you guys, this is a little bit rough of like, okay, let's factor this out and then think about what has to happen to everybody in the little parentheses here to factor it out. Like I get that that's tough, but this saved me from being like, oh, what if I forgot? Like, yeah, you're not going to forget. Just do people balk. They're like, I don't want to solve 5 linear equations. Like, okay, when you first started algebra in your first algebra class, and you had to solve 5 linear equations, and they had pies and fractions, and oh, good Lord, that was horrible. That go ask an algebra one student. Like, they're not going to be happy about this. They're going to say this is too much work. But now that you've finished algebra 2, you're in trigonometry, you are better at math than you were a couple of years ago. Solving 5 linear equations is not the stress-inducing task that it used to be. I mean, maybe it is, which means you should practice, but this is not. This is no longer a big deal to solve these 5 equations. This is just like, yeah, whatever, just solve the 5 equations. Not a problem. Fractions get common denominators. By the way, I understand that fractions are still hard for everybody, and I get that. And for me, fractions lost their power to be, I lost my fear of fractions, power of fractions. When you take calculus one, fractions cease to become a threat. I mean, they're still a little tricky that you're going to have to deal with, but the one thing you'll learn in calculus is fractions are constants. And then, and anybody, the moment you are in calculus, maybe not the moment, but a couple of weeks in calculus, you're like, oh, they're constants. Like, oh, they don't have a lot of power. No, they sure don't. And that's when they stopped being scary. Okay, so you have a little bit longer to go in order for fractions not to be scary, but it is coming where they will not be as scary as they are right now. But I developed this because, back when I took trigonometry, because I was like, I don't want to work that hard. I don't want to have to remember extra formulas. I don't want to have to remember the fact that I don't want to do any of this. And since I need these points anyway, rather than try to wrestle with figuring out my period and figuring out my phase shift like, no, that's a lot of work. If I just do this, it's all automated and I don't have to think about it. So that's why I came up with it this way. And this is how I teach it now. So again, you are welcome to use the problem in the book. You are welcome to use other people's methods. The tutors have wonderful ways of graphing trig functions. There are plenty of other YouTube videos in the world that will show you a different way of doing this, and it's fine. Do which way is comfortable for you. That's the important thing. But I am looking for these 5 points. So it does kind of push you into graphing it the way that I want you to graph it. But the other ways will get you these points as well. Okay. So I'm going to say thank you very much for watching the video, and thank you very much for watching. And I hope that helped out. I hope that helped you out a lot. All right. We'll see you next time.